Our objectives are to understand what an index is, to multiply and divide with indices, and to work out a power of a power. Okay, let us remember that if we have 5 squared or 5 raised to the power of 2, it means 5 times 5, which is equal to 25. The same way, if we have 5 raised to the power of 3 is equal to 5 times 5 times 5, which is equal to 125. That means that if we have 5 raised to the power of 4 is equal to 5 times 5 times 5 times 5, which is equal to 625. So if we have 5 raised to the power of 5 is the same as 5 times 5 times 5 times 5 times 5, which is equal to 3,125. Now, so how would you explain how to work out 5 to the power of 8? Okay, so it means that it is 5 times 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 5. 1, 2, 3, 4, 5, 6, 7, 8, which is equal to 390,625. So 5 to the power of 8 means 8 fives multiplied together. Okay, as you can see, the answer gets bigger, very big, quickly. Now, so how do we multiply indices? Okay, so let's say we have 2 raised to the power of 5 times 2 raised to the power of 6. So we are now multiplying indices. Okay, so it means that, okay, we have here, okay, so 2 raised to the power of 5 means we have 2 times 2 times 2 times 2 times 2. Okay, then, okay, times, okay, 2, okay, times 2 raised to the power of 6. So we have, okay, 2 times 2 times 2 times 2 times 2 times 2. Okay. So we multiply this 2. Okay, we have two groups. Okay, this one and this one. Okay. So that means that if we combine them together, okay, so we will have, that means that we can say that it is 2 raised to the power of how many? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in other words, we have multiplied 2 11 times. Multiply 2 to itself 11 times. So 2's 11 times. So in other words, we can say that we can see the link that when we have 2 raised to the power of 5 times 2 raised to the power of 6, okay, it is the same as 2 raised to the power of 11. So if we can see, we simply can add the exponent. So 5 plus 6 is 11. So we have 2 raised to the power of 11. Then we come up with the general rule that we can say that if we are multiplying with indices, so let's say we have a raised to the power of n times a raised to the power of m is equal to a raised to the power of n plus m. So let's say we have this example. Let's say we have a raised to the power of 2 times a raised to the power of 5. We will have a raised to the power of 7. Okay, what about when we are dividing integers? What do we, indices, with indices, not integers. Okay, so let's see. In dividing with indices, let's say we have, okay, let's say we have 5 raised to the power of 7 divided by, okay, 5 raised to the power of 3. Okay, so what will be the answer for that? How do we do? So what we have to do is we have 5 raised to the power of 7 divided by 5 raised to the power of 3. Okay, so that means 5 raised to the power of 7 means 5 times 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, 7. Okay. Divided by 5 raised to the power of 3 means 5 times 5 times 5. Okay. Then what should we do? Okay. Now, we can cancel this one. 5 here, 5 here. 5 up, 5 down. 5 up, 5 down. Okay, so what left is we left with okay. What we have is we have 5 times 5 times 5 times 5, okay, which is equal to 5 raised to the power of 4. Now, can we see a link when we divide, okay, that with indices? So let's say we have 5 raised to the power of 7 divided by 5 raised to the power of 3. Okay, do we notice something? That, okay, to get 5 raised to the power of 4, look at the exponent 4. So what do we do with 7 and 3 to make it 4? So that means 5 minus 7 minus 3. So that is 4. So 5 raised to the power of 4. So in other words, we subtract the exponent. Okay, then it will give us, okay, the rule that when we divide numbers with the same base, what we do is we subtract the powers. So let's say we have n, okay, a raised to the power of n over, okay, a raised to the power of m. We have a raised to the power of n minus m. So let's have example. We have a raised to the power of 5 over a raised to the power of 2. So we have a raised to the power of 5 minus 2 is 3. Okay, now, what if we have brackets? Okay. Okay, so let's say, for instance, how could we simplify? Okay, let us simplify we have 2 raised to the power of 3, okay, and then to the 4th power. So what should we do with that? So the power of 4 means that we want to have 2 raised to the power of 3 multiply by itself 4 times. Okay, so in other words, we can have, okay, 2 raised to the power of 3 times 2 raised to the power of 3 times 2 raised to the power of 3 times 2 raised to the power of 3, which is equal to, 2 raised to the power of 3, which is equal to 2, we have 3 plus 3 plus 3 plus 3. Okay, 1, 2, 1, 2, 3, 4, which is equal to 2 raised to the power of 12. So what is the short way of doing it? Can we see the link? So to get 12, 2 raised to the power of 12, we can simply multiply 3 here and 4 there. So if we multiply it, we have 2 raised to the power of 3, okay, to the power of 4 is equal to 2, and then raised to the power of 3 times 4 is equal to 2 raised to the power of 12. Okay, so let's generalize this one. Okay, therefore, if we have, okay, a raised to the power of n, okay, to the power of m is equal to a n m. We multiply m times m is nm. So let's have example. So let's say we have, okay, a raised to the power of 4, okay, and then raised to the power of 5 is equal to a raised to the power of 20. Okay, so let's have the next one, which is with, okay, special powers. So there are 2 special powers that you need to be aware of. So you can discover the first of this for yourself by simplifying. Okay, let's say we have, okay, so we have special power. Okay, we have, let's say we have a to the power of 6 divided by a to the power of 6. Okay, so using the rule that, okay, for dividing indices, okay, wherein we have to a, okay, and then 6 minus 6 is equal to a raised to the 0 power. Okay, which means that, but when we know that any non-zero number divided by itself will give us 1, because a to the power of 6 divided by a to the power of 6, it will give us 1. Any number divided by to itself, okay, it will give 1. Okay, will give us 1 as the answer. So therefore, a to the 0 power is equal to 1. Okay, so we say that, okay, a to the 0 power is equal to 1. Okay, then the other one, let's say, okay, the second special power is, let's say for instance we have a raised to the, okay, I need to use blue. A to the power of 3 over a to the power of 2. So we have, if we have here a times a times a over a times a. Okay, so let's cancel the, okay, 1a here, cancel with the low, okay, the a down, okay, a up, okay, cancel that one, cancel that one. So what left is a. Or if we will apply, okay, the rule, which is a, okay, over, okay, a to the power of 3 and a to the power of 2 will give us a 3 minus 2, which is equal to a to the 1, okay, and which means that if we have that exponent 1, okay, so we have will give us a. So therefore, we can say that a to the power of 1 is equal to a.